Welcome everyone back to the weekly weather podcast, and this week we're going to be having a look at what climate effects we could be seeing from the Tongan volcano. I think most of you have probably seen the images from Tonga and surrounding area. Truly quite a devastating volcanic eruption, and I do want to first put my thoughts and prayers out there for all those affected by this eruption and, of course, the following tsunami. But in this podcast, we're just going to be mainly having a look at what the effects could be on global climate. Now, some of you may not want to stick around for the whole podcast, so I'll put out my thoughts first of all. I think this will have some knock-on effects, but I don't think it'll be anywhere near as drastic as some people may make out. I'll show you quite a lot of evidence that some climate experts and volcanologists have put out there of the impacts potentially from this, because remember, we don't get these sort of massive volcanic eruptions particularly often. As you'll see in this video, we've had about 3 in the last 100 years. To this extent, they're not as widely known because when we weren't really in the sort of smartphone era, so there's not many images, cameras, satellite images, stuff like that. We didn't have any of that for the previous large volcanic eruptions, and I do think this eruption will have a knock-on effect with the climate, but I don't think it'll be anywhere near as substantial as some may think. This eruption, of course, was quite large, but it's not as large as some we have seen previously that have caused some global cooling. But I think it'll be something like the butterfly effect with this, where it's such a big explosion, such a lot of energy and pollutants have been put into the atmosphere that there will be a knock-on effect. Whether it's some massive global cooling, I think is very, very unlikely. But if there are, I do think there will be some impacts down the road, and maybe in a year's time we may be seeing some form of weather patterns, and we may think potentially this may have been sort of triggered, may have been helped by the impacts from this volcanic eruption. So we'll go through, first we'll have a look at the actual eruption, and then we'll go through what the sort of pollutants impacts could be. So we do start out by having a look at the volcanic shockwave. Now, I do want to point out in this podcast, I am showing images and videos because I've been seeing a lot of comments. Some people saying it would be nice to get a bit of accompanying images and sort of charts and stuff whenever I'm talking about some of these events. So I'm going to be putting some images up. It's not essential, of course. You can listen to the podcast without these, but it's just really in this scenario, it's really quite good. And then I'll be going forward doing some images and videos, as I know some people do quite like having something to view. So first I'll have a look at, it's quite a far out image of the Tongan volcano. It's shockwave, called in tidal waves, of course, and this is from a scientist, Dr. Eric Ding. Now this is widely shared. It's from The Wonder of Science. You can see this if you just look Tongan volcano up in Twitter or online. You'll be able to see this video or very similar. So I do run it through. You can see pretty mundane, and then you can see a massive eruption, and you can see that shockwave spreading out, and it repeats. And if I just do pause it there, you can see with where I'm just pointing the mouse, you can just see on the wide outer rim of this, you can see a shockwave going around the world, and this shockwave has been seen all the way around the world a couple times now. Now, I won't be able to look at it in this video as it's not particularly relevant, but if you have had a barometer in the UK, if you do have a barometer at home, out in the garden, you will have seen, if you've got some data from it, small pressure rises over the last couple of days, only about 1 millibar, but that is the shockwave from this volcanic eruption going round the world, and I've seen it's gone around a few times now with these shockwaves. And remember, these are thousands of miles away from the UK. It's almost the other side of the planet. We're almost the furthest country away, really, or one of the furthest away from Tonga in the centre, or in this case, Western Pacific. So it is really far away, and we're seeing truly exceptional conditions. Just shows you the amount of energy that has been pumped into the atmosphere from this one volcanic eruption. And if we continue playing the video, almost 8 million views. You can see again those shock waves spreading through. This is from a slightly different angle. You can see those shock waves moving through, multiple different shock waves. So that's why we're seeing, of course, initial sort of shockwave, then we're seeing a tsunami following behind it, and of course a few different shockwaves going around the world. And of course it was, truly massive eruption, and I do really feel for anyone who is being affected by this. Luckily, it's not been hugely damaging in terms of course, there's been a large tsunami, but if this was near more populated areas, I don't know, of course I feel for everyone in Tonga, but if this was, for example, near Japan again, or near more populated areas, so we saw the earthquake, of course, about a decade ago in Japan, saw that tsunami, but if we saw an event similar to that with a volcano near more populated areas, we could have seen even worse impacts. And of course, there was about a meter high tsunami that it did impact Tonga in its many islands and its capital, of course, and it has devastated areas. And of course, ash is now falling. And I do pray that they can recover from this. But I also do want to show a video from Fiji. This is 470 miles away on Fiji Islands. Now, this is an extremely large sonic boom from that shockwave, and it just shows you 470 miles this wave has travelled all the way from the volcanic eruption. And I just want to make sure if you are listening and watching this, do mind out. This is going to be very loud. I'm going to hopefully just take it down in the editing. I'll try and suppress the noise from this, but this really is a loud sonic boom. So I will just play it now and let you listen.
Check all of that out. Oh, fuck! Holy shit! Fuck! Alu!
So now you've listened to that. Sorry if there's any, if you heard any bad language there, of course. I mean, if you were in that situation, I think a lot of people would have been shocked like that. Of course, Fiji did also see a bit of a small tsunami, but nothing too significant. There, of course, higher waves. And I've seen various other videos from around the world showing larger swells, larger waves, even down into parts of Asia and the Americas, South America as well, showing some large waves. Some saying it's maybe remnants of the tsunami, but again, I'm a bit sceptical of that because of how far it has travelled. Considering it's only about a metre or two high in Tonga, I doubt that it's massively significant the other side of the Pacific. But you never know. This could. I'm not an expert with this, of course, and this event is truly quite a rare event. It's really the first, as I said at the start of the video, that we've had in the modern era of satellites and smartphones. Now, I do want to go through a few Twitter threads, because remember, this event is still going on. We're still seeing a lot of this pollutants pumping into the atmosphere. Still an eruption is going on, but the main big explosion has happened. So there's no research papers out there, no massive amounts of data. All we've got is scientists who are at their computers getting all the data in, and the quickest way for them to get it out is through Twitter. So we've got here Professor Simon Khan showing the first stratospheric volcanic eruption 2022, the Tongan Volcano, and this is its sort of initial eruption, because it's weird with volcanoes. They go through a long eruption stage. Eruptions can be weeks, months, and they can culminate in just quite low amounts, or in this scenario they can be quite moderate and then explode very quickly. So we actually were seeing quite a big volcanic cloud on the 13th to 14th of January. You see 0.05 teragrams. That is teragrams. So that is a truly exceptional amount of mass of sulfur oxide going into the atmosphere, which is the main pollutant from volcanic eruptions that can cause climate impacts. And you can see this initial volcanic cloud is not enough for any climate impacts. Of course, perhaps small downstream effects, but nothing significant where we can say it's guaranteed to come from this eruption. However, you can see on January the 15th another GIF of the huge eruption at 4 a.m. Massive eruption here from the volcano, the Tonga volcano. And you can see here, look at the sulfur oxide from the January 15th cloud, and the sulfur oxide columns, as he said here, not too extreme, but they are getting quite high into the atmosphere, just less than 20 Dobson units, and I'm no expert with this, but for a Pinatubo scale event, we'd expect more than 100 Dobson units, and that will come relevant later in the podcast as I show you, as he's comparing it to past events that we have seen that have caused some climate impact. So you can see there, nowhere near as big as a previous eruption that has caused climate impact. So I just wanted to get that in there. And you can see the westward transport of the sulfur oxide cloud from or sulfur dioxide cloud from the Tongan confirms that most of the gas is in the stratosphere where the winds are easterly, and of course I have to wait for more data to estimate the mass, because this is January the 16th, and you can see here this is the latest data, so 0.4 teragrams now of sulfur dioxide in the stratosphere. And you can see the column here going up, and you can see the amounts spreading towards sort of New Zealand, Australia, into the southeast of Asia. And of course, earlier we said 0.05 teragrams from just sort of the initial eruption. So, yeah, 8 times the amount of sulfur dioxide now in the atmosphere as a result of the massive explosion. And you can see again, massive volcanic cloud up in the stratosphere across northern Australia towards the Indian Ocean, and it will remain detectable for some time. Again, there's a lot of graphs here that I'm not particularly I don't particularly know exactly what is going on, but once again, the headline is volcanic aerosol cloud reaching altitude of up to 30 kilometers. That is huge heights. Now remember, when we were doing sort of winter forecasts for the UK, we are looking at stratospheric impacts, stratospheric warmings, and things like that. Remember, this huge amount of energy has been pumped into the stratosphere, pollutants, particles pumped into the atmosphere and the stratosphere, specifically. So it just shows you that this could, have some effects. And I've stated in this thread, doesn't expect to be massive climate impacts though. And then if we do move through, you can see drifting westwards again, more just updated cloud amounts. And really, really an exceptional eruption with this. Now, if we do have a look at another graph from Gavin Schmidt, this graph is basically showing the anomaly temperatures from 1950 all the way to present day, showing the land-ocean index, and it corrected for the ENSO, because remember, La Nina, El Nino events does give this oscillation of land-ocean temperatures. Because remember, the climate doesn't, as it is warming, it doesn't just go up in a straight line. It does go up and down, but on a general upward trend. So this is corrected to sort of take out the effects of the El Nino, La Nina, and you can see the last 3 big eruptions. You can see Mount Agung, I may be butchering these names, and I'm not particularly well known with these. El Chichon, I think, or El Kikon, maybe, I don't know, and Mount Pinatubo. Now you can see this was in the early 1990s, so we do have, of course, satellite data for it, but no smartphones, so we're not getting, it's not that well known. And you can see with all 3 of these eruptions, significant decrease in ENSO corrected index, land ocean index. So you can see these three eruptions have all caused a cooling down of the atmosphere. Probably most significant would be the Mount Agung and the Mount Minatubo. You can see the El Kikon one, again, probably butchering that, was a warming actually with that, but you have to factor in the La Nina, El Nino, and it was in fact stationary, if not a cooling. Now, with this eruption, it's so difficult to say what we could be seeing with this. Again, as you saw on the previous thread, nowhere near as much as previous eruption of Mount Minatubo, and I do suspect we won't be seeing anywhere near as much of that in terms of cooling. And no one at the moment is saying there's going to be massive climate impacts. Experts out there are not saying there's going to be massive climate impacts. So if you are worried, there doesn't look like, of course, there will be a massive global cooling or sort of volcanic winter coming. That's very, very unlikely. But as I said at the start of the video, we could be seeing something like the butterfly effect, where this amount of energy being put into the atmosphere, downstream it could have some impacts. Of course, this will change the atmosphere. It will sort of change stuff around. And of course, I'm keeping eyes peeled, and I think a lot of people are keeping eyes peeled on the actual live computer models, what's coming out at the moment in terms of the climate and the day-to-day weather, whether we see any impacts from this. It'd be very interesting to see if we suddenly see something like a stratospheric warming crop up or a stratospheric cooling crop up, whether that's in the southern hemisphere or the northern hemisphere. Again, we've only had a few of these eruptions, and the amount of energy particles pumped into the atmosphere, it's so difficult to model it. I remember the computer models at the moment are struggling to model weather 7 days away, with years and decades of small changes from scientists and programmers to make it accurate. And there's no way that we're going to have an accurate sort of forecast for what could happen with this eruption. There's no way, but there definitely will be some climate impacts from this, but I don't think they will be massively extreme at this stage. As I said at the start of the video, it could be a scenario where next winter or during the summer or even the next few weeks and months, something could happen, and some may say this is attributed to the volcanic eruption. Some may say this part of the stratosphere, this ocean sea surface temperature, the El Nino, the La Nina, suddenly flipped or not as it was forecasted a couple of months ago, and that again downstream impacts. So there could be some impacts from this, but I don't suspect it'll be anything too great, and it won't be an exact science. There's no definitive answer here, and if we do generally have a look at this is just a general image I pulled off of Google to show what the impacts could be. This is sort of like GCSE geography sort of images here, but it just shows it quite well, and it's very easy to explain through this. You can see massive ash cloud, sulfur dioxide, various other pollutants, and again the sulfur dioxide is the main issue, creating sulfate aerosol, and of course you can see it acts as a layer in the atmosphere that reflects sun and infrared radiation, different sun rays, UV rays, stuff that generally is warming the surface, increased planetary albedo, if you know your physics well, and that is why there's general cooling trends with these eruptions, because wherever that sulfur cloud goes, wherever it covers, how widespread it covers, that will inevitably cool the area beneath it. Whether it's massive or whether it's small, all depends on each eruption, how spread out the cloud is, and how much mass. And that's why earlier in some of the Twitter threads we were seeing that the mass was nowhere near as much as previous eruptions, and that's why there's higher confidence this won't have too extreme of an impact. But you can see again, precipitation changes, again, it can impact sea surface temperatures, ocean circulation, impact river runoff, surface cooling, all these things can produce more cloud amounts. So there are various impacts. It's not a well-known science simply because we don't get too many of these massive eruptions. We've had many thousands probably in the last few thousand years, few million years, but in the era of human science, being able to look at this with a lot of data, we've had very, very little. So it's very difficult to say. What could come of this. So in summary, do I think this will have massive effects on our climate? No. Do I think we will be going into a massive period of global cooling? No. Do I think there could be some downstream effects, some climate impacts, some small weather events or major weather events where some people may attribute it to increased surface temperatures, surface cooling, flip from La Nina to El Nino, stuff like that. Do I think that could happen? Very possible. There could be some smaller impacts, some downstream effects, the butterfly effect, as I've said throughout this video. So yeah, don't think there'll be massive impacts, but could be some downstream effects. So I hope you enjoyed this podcast. A little bit shorter than, of course, last week's. But I don't want to be banging on about this too much because, of course, I don't know that much about it. Not many people know too much about this because it's an ongoing situation. Every day we get more data of how the sulfur cloud and ash cloud moving through the atmosphere, where it is in the stratosphere and what direction it's going, and how spread out it is, how much mass there is, whether we see more eruptions or more major eruptions with this volcano. It's very much, as I've said, an evolving situation, and it could change what we see with this. So at the moment, as I said, initial reaction to this, don't think we have massive impacts, but could have some small downstream effects, knock-on effects over the next few months, maybe even the next year or two. So yeah, don't be worried if you are seeing some people scaremongering about this having massive impacts on our climate. It won't. But as ever, just shows you the power of the planet, and that humans really are at the mercy of Mother Nature. And so these climate impacts, whether it's, of course, caused by volcanic activity or by anything else. So yeah, really, really quite an exceptional event. And of course, I want to pray for everyone in Tonga. Hope they do have a good recovery. And we do, and this does increase awareness of volcanic activity. We get more research into it because I don't want to scaremonger by any means, but volcanoes are one of the sort of biggest things that could put humans in jeopardy, really. We have so many volcanoes around the world, and this is not a massive eruption. It's a very big eruption for the last sort of 20, 30 years, but in terms of the grand scheme of things, in terms of previous eruptions that we have evidence for over the last hundreds of years, thousands of years, there could be a lot worse that could come from an eruption. So hopefully this does increase awareness, increases funding, and we can learn more about how often we'll see these volcanoes, whether we can forecast these eruptions a little bit better, and how we can sort of reduce the impacts, and of course what effects it could have long term on things like the climate. So thanks for listening. I hope you've enjoyed this podcast. Make sure if you enjoy the podcast, make sure you subscribe, like, of course, and if you want to hear this earlier on a Wednesday, sign up for channel membership.